This is a new problem. This was not in your notes before. All right. When does G have a maximum? Okay, so now we use little g. Remember before I said this does not always have to be big G. You have to look at this and recognize, what does this say? Just by calculus, translating. This function equals the area under this function. Alright? So basically I'm just asking you, at what point from 0 to some x value, at what point do we have a maximum? What is G? An accumulation function. When do we have a maximum what? Maximum area under the curve. So just from looking at this graph, just look at this graph and nothing else. We're not even doing any calculus, just using common sense. If you understand what this question is asking you, you should be able to get the answer. Alright? From 0 to what point will I have the most area under the curve? Okay, starting at 0. Accumulating area, I'm getting area, I'm getting area. Okay, I get to this point, I have a lot of area. Keep going, am I still getting positive area? The answer is yes, I'm still getting positive area. Okay, now at this point, what type of area am I getting? Negative, this is all negative area. Okay, so I have a lot of positive, now I'm getting negative. At what point did I have the most area? At B. B, I had the most area. Because this was all positive. Common mistake would be to say A, because it's a high point, but I'm still getting area, positive area. This is all positive. At this point, I'm starting to get negative area. So I'm losing area. So point B, I had the most area, the maximum amount of area. You could figure that out just by looking at the graph. You don't need to know any calculus. You just need to know what this means. G is accumulation. When is G a maximum? G is a maximum when I have a maximum area. Alright? Now the calculus behind it. How do I find a max or min? Sign chart of the derivative. Alright. So G prime, the derivative of this would be 0 to x. Just plug in x. G prime equals f. Sign chart. Okay? I want to find the zeros of G prime. That's the zeros of F. This is F. Where does F have zeros? At 0, at B, and at D. Now looking at F prime, I'm looking at F. F has zeros here, here, and here. Now fill in the signs. From 0 to B, all of these values are positive. Not looking at the slopes, just looking at the values. From B to D, all of these values are negative. Up, down, max. There's a maximum at B. I get the most area at B. Just real quick, going into justifications. How do I justify that? I would say point B as a max because there's a change in sign of the derivative from positive to negative. We haven't done a lot of max-min problems recently. They're coming back. Okay. Where would there be a minimum? There would have to be at 0 or at D. We don't have enough information to tell which one though. Last one. Where does F have a maximum and a minimum value? Alright, so here I use F. Remember, it does not matter what letter this is. You have to look at this and say, I got a function equals area under curve. This is an accumulation function. Max min. How do I find a max min? Derivative. Okay? F prime. The derivative of this. We're going from a number to, if you can't see that, F, 5 squared, sorry, and from a number to 5x squared minus 20. Alright? So this is the chain rule problem. I'm still going to take this and plug it in for t. 5x squared minus 20. Plug that in for t. So we had t squared, so now I have this squared. And chain rule kicker. What's the chain rule kicker? 5x squared minus 20. 10x. The derivative of this is 10x. So that's basically the calculus. The rest, I'm doing a sign chart for a very easy algebra problem. You have to realize they ask for max, min. The derivative of f, in this case, would be the derivative of this from a number to an equation. Plug in the equation, chain rule kicker. Find the zeros. The zeros of this. On the outside, my zero would be 0. On the inside, 5x squared minus 20. 5x squared equals 20. X squared equals 20 divided by 5. 4. Square root, x equals plus or minus 2. Okay, so my zeros are 0, positive and negative 2. Alright, fill in sign chart. This is always going to be positive. Why? Because it's going to be squared. So that makes this real easy. Just look on the outside. If I plug in anything that's negative, I got negative, negative, positive, positive. Okay? So, from looking at this is a great example. There is no max or min at negative 2 or 2 because there's no change in sign. There's a minimum at 0, and the maximums, there are no maxes. They'd be at negative infinity and infinity because we have no endpoints. No endpoints, so in this case, we would not have maximum values. Okay, so that we have a minimum what? Minimum area at 0. At 0, we have a minimum area. All right, in this example, we have no idea what this graph looks like. Last problem, look at the graph. Where do we have the most area? That's pretty easy. Here, we don't have a graph, so we got to know the calculus. Okay, that's it. Now, hopefully you guys get a good feel of this. I'm going to fly through these notes real quick. No more than 5 minutes, maybe 8 minutes. Boom, right through all these notes. See if you guys have any questions. Hopefully you wrote down some questions while you were looking at this video and copying down, filling in the notes. I'm going to send along a little worksheet for you guys to work on the next couple of days. Again, I apologize for you guys doing this work, but let's be honest, you had a whole week off, so quit bitching. I'll see you guys on Monday.